so we're back looking at page 2, which I think is questions like 5 through 9. First one, right, this one's kind of a doozy. Look which expression is equivalent to x to the power of 8 minus y to the power of 8. Anytime I have ones like this, I'm trying to just, I don't know, look to see if I maybe see some sort of like pattern of questions we've seen before, right? And just know I'm going to be able to knock out some things. Here, right, I kind of look at this, I'm like, well, you know what? This looks like a difference of perfect squares, right? So if I'm looking right at just this little piece first, right, to try to make it easier on myself instead of trying to multiply all this through, I know, right, what am I looking at? Difference of perfect squares would mean, right, if I'm saying x to the power of 4 plus y to the power of 4 times x to the power of 4 minus y to the power of 4, right, that's going to give me this up here, right? Right once I do that, well, you know what? Now I start to see something that might make a little bit of sense, right? Well, I do it once. Guess what I just created? Another difference of perfect squares, right? This is going to be what? X squared plus y squared times x squared minus y squared. And lo and behold, what did I just create? Another difference of perfect squares, which is just what? X plus y, x minus y. All right, so something that kind of looked crazy. I just used my knowledge of difference of perfect squares, and now I have what? X to the power of 4 plus y to the power of 4 times x squared plus y squared times x plus y times x minus y. Answer choice number 3, and we got lucky. All right. Number 6, right? This one, research assistant receives a first year salary of 90 grand and a 2% annual raise throughout the first 10 years of employment. In total, right? That's the big thing. In total, how much money will be earned over the first 10 years to the nearest dollar? So what does that mean? If I'm thinking total, I want to figure out how much money I made, right? Or the research assistant made for over those 10 years, right? Not at the first year, not at the 10th year, right? I have to add them all up, right? In this case, right, I would just grind it out and basically say, right, in my first year, right, how much did I make? I made $90,000. Right? In my second year, well, what did I have to do? I had to do what? I had to basically take my $90,000 and I made a 2% raise. Well, what's a 2% raise? It's 1 times 1.02, right? Because that's my 2% raise, and I have to multiply it by 1 because I'm getting a bigger number. Once I do that, I'm going to say 90. I'm getting something like 91,800. And then what am I doing, right? I'm not going to do all these numbers, right? But in the third year, I'm taking what I made in my second year, the 91,800, and what am I multiplying it by? 1.02, right? If you just kind of like make your own little table here, you can do it for all 10 years and then add them all up, right? I would always, since it's always saying to the nearest dollar, just keep it at the nearest dollar so your calculator doesn't go crazy. Once you do that, right, you're going to get a number that's super similar, right? Even over here, right, I know 1 and 2 make no sense, right? Because if I'm adding up, I already went over that. So it's between 3 and 4, and I think at the end it becomes answer choice number 4. So we should be good to go. If I look at number 7, right, another like stats question, you got a cafeteria food manager studied the lunchtime eating habits of a group of employees in their office building. The purpose of the study was to determine the proportion of employees who purchased lunch in the cafeteria, brought their lunch from home, or purchased lunch from an outside vendor. So right in this case, what did they do? I think the key word here is, right, the cafeteria food manager, they just studied, right? Did they like do any sort of experiment or simulation, or did they ask anything? All they did was really study and watch. So in this case, right, it would be an observational study because they just observed, right? They did nothing else. Moving on. Number 8, I would say is definitely a tricky one. Given 3 is a root of f of x equals x to the power 4 minus x cubed minus 21x squared plus 45x. What are the other unique roots of f of x? In this case, right, if you know 3 is a root, You could do a bunch of different ways here, right? You could put all of these into, think about like the remainder theorem, right? And substitute in the -5, the -3, the 1, the 0, and see what you get. Like right off the bat, like if you put in 0 into all these, you know you're going to get, right, 0 minus 0 minus 0 plus 0. You know 0 is going to be a root. That's one way, right? Remainder theorem. Another way, what I did, I actually just graphed it. And when I graphed it, I got something, right, like a really big like curve, right? But what did it do? It basically went through a couple roots. It went through the root of -5, it went through 0, and then it also went through +3. The reason why it's saying this little like unique root over here is because technically, right, like if I draw this like really quickly, right, you got 0, got 1, 2, 3, 1, 2, 3, 4. I'm thinking it kind of looks like, let's see, this one happens. All right. We know, right, since it kind of deflected or like reflected right off the x-axis here, that this would be a root that would show up twice, right? So the root 3 actually shows up twice, and the other two, right, -5 and 0, right, where they cross the x-axis would be my other unique roots. So my answer choice would be answer choice number 2. Use your calculator. When in doubt, use your calculator. Number 9, kind of getting cut off by my video, right, but that's fine. You have two equations, right? Find the point of intersection in quadrant 2. That's your first little hint, right? We're thinking quadrant 2 means what? My points have to be negative, positive. So look at that. Right off the bat, I know number 1 doesn't work. This one I can't just easily put into my calculator because it's not solved for y. So you could either solve for y, or in this case, I'm thinking system of equations. This is one I can actually do, right? If I know y equals -2x, well, guess what? Let me put the -2x into my y squared, right? If I do that, I'm left with what? X squared plus -2x squared equals 5, right? I think this is the easiest way to do this, right? This becomes what? X squared plus 4x squared equals 5. And if I want to start to find like my roots, right, or solve this, I want to subtract the 5, add these like terms. I'm left with 5x squared minus 5 equals 0. Well, let me try to find some roots. I could add 5 on both sides. Gives me 5x squared. So I actually did a little bit too much work over here, but that's fine because I brought the 5 back over, whatever. I divide by 5 on both sides. I'm getting x squared equals 1. Take the square root. X equals not just +1, but what also? -1, right? So that means, right, the +1 is not going to work as a solution because it's not in quadrant 2. The -1 will. Let me take the -1 and let me just put into my the first equation it gave me, right? So I'm going to say y equals -2 times -1. What does y equal? +2. What does that mean? My coordinate point? That means my coordinate point for at least one of the intersections would be -1, +2, right? And if I'd done the same one, right, let's say this was a short answer and you had to find both answers, right? The other one would be +1. I put that +1 in. I'm getting 1, -2 as my other answer. Which one's in quadrant 2? It's being cut off, but it would be answer choice number 4. All right, cool. Hope that helps.